What's up, Econ Studs? Chapter 27, we're back with finance continuation, looking specifically in this case at present value and future value. I want you to understand how these tools work and why they're important. So we're faced with present value first, which basically means the amount of money needed today to produce an amount of money you want in the future. And we're given this equation here, where we have x over 1 plus r to the nth power, where x here is the amount of money I want. R is the interest rate, and n is the number of years. So it's going to allow me to say, if I want to have x value in the future, how much money do I need today? So let's go for example. I would like to have $200 in the future. And let's say the bank is paying at 5% interest, and I want to have that $200 in 10 years. How much money do I need in the bank today to get that $200 in 10 years with 5% interest? And the answer, if you do the math, is $123 in the bank today. You can kind of invert this relationship and also look at future value, which our equation is x times 1 plus r to the nth power again, where x is the amount x is the amount I currently have, and r is interest rate, and n is number of years again. So in this case, let's say I currently have, let's pick something simple and easy. Let's say I currently have $100. And I put it in the bank. And the bank is paying 5% interest. I'm going to hold it in there for 10 years. How much will that money be in the future? If I do the math on that, it's going to equal $163. Okay, so that's present value, that's future value. Present value, I want a certain amount in the future. How much do I need today to get the future amount? Future value is I have this much money right now. How much will it be worth in the future? And I have my little equations with x and r and n being the important variables to figure this out. The question we have is, well, why is this important? What use will this have when it comes to finance? And let's take the example of General Electric. Let's say that GE is thinking about building a new plant. That's going to cost them $100 million to build this. But they expect in 10 years from now, the revenue on this plant will be $200 million. The question is, should they build this plant? Let's go ahead and use present value to figure out if they should build this plant or not. Again, present value is x over 1 plus the interest rate to the number of years it's going to take to get that revenue. And let's say that I'm looking to say I'm going to have $200 million in revenue, and I'm going to have that in 10 years' time. And let's say the bank right now is paying, to keep it simple, 5% interest. So what I'm trying to figure out right now is it make more sense for GE to take $100 million and use it to build the factory, or does it make more sense just to keep that money in the bank? This is saying I kept that money in the bank, or I would keep this money in the bank. So how much money would I need to keep in the bank to get to $200 million, which is what I would get in 10 years if I spent $100 million to build that plant? If I do the math on this, the answer I get is I would need $123 million in the bank today to sit for 10 years to get $200 million. Where if I built the plant, it would only cost $100 million. So should I build the factory? Yes. It's $23 million cheaper to build the factory to get $200 million than it is to put the money in the bank. But what happens if the interest rate changes? Now, instead of the bank offering 5%, let's say they are offering 8% and still 10 years. This number comes out to be $93 million. GE would only need to keep $93 million in the bank at 8% interest for 10 years to get to the $200 million mark, where the factory would cost $100 million. So should they build this factory now? No. It's more cost efficient just to put $93 million in the bank than it is to build this factory to get the same return of $200 million in 10 years. So the book's going to talk about compound interest and how this works here to get this number. I'm sure that you either cover that in math class or can read about it. This will also talk about the rule of 70, a nice rule of thumb in finance that how long it takes for your money to double depends on the interest rate. So check that out. But the next thing I want to cover here is that these interest rates, you know what? They're not constant. You're not always going to get 5% for 10 years or 8% for 10 years. And so we introduce risk into the equation. And GE doesn't know exactly should it take out this loan or not to build this factory. And the reality of the matter is that most people are what's known as risk adverse. They don't like to have a lot of risk in their lives. And the book talks about these psychology experiments that are out there about flipping coins and wins or losses. And so the big thing is humans want to guard against risk. And what are ways they can do this? There are two important ways. One is to buy insurance. Insurance, which you should read about, is you pay a little bit of money today for protection if something really bad happens. You pay a little bit of money every year for fire insurance, and if your home burns down, the insurance company will rebuild your house for you, and it's not stuck with you having to have the whole house, build the whole house yourself. The second way that we can avoid some risk is diversification. I'll let you read about idiosyncratic versus the market risk and how we can guard against, hopefully, idiosyncratic risk through diversification. The chapter then kind of ends talking about different ways that we can analyze the market through these financial tools. And it's going to introduce you fundamental analysis versus the efficient market hypothesis theory. The traditional way of thinking about it is fundamental analysis. We have smart people, they analyze companies, they try to determine whether a stock right now is undervalued or overvalued, and make a decision whether to buy it or not based on that information. People like Warren Buffett are famous fundamental analysts. The other one is the efficient market hypothesis, which is basically saying that all information out there is baked into the stock price, and so the stock price is always an accurate reflection of what it is. There's no need to analyze a company because the stock price is correct. Well, is this correct or not? I think most people still kind of rely on fundamental analysis, but that being said, a lot of people who do fundamental analysis don't have spectacular returns. Again, we don't have a crystal ball. Niederhoffers exist out there. They could be lucky for a while, as Taleb would say, but eventually they're going to blow up. And oftentimes these people that are paid to manage portfolios and be fundamental analysis, they do a poor job just trying to outperform a stock index, which is all the stocks out there. So I encourage you to read chapter 27. The hard part here is this idea of present value, future value. Hope this video helps you with that. And we'll go from there. When in doubt, graph it out.